All right, so lecture number 3, covering probably one of the more important topics, and that's going to be ST elevation. So, a lot of what your job is contingent on is determining whether people are having a myocardial infarction or not. And in order to do so, we use ST elevation as one of our primary criteria. So, we're going to get right to it. So, if I'm looking at cardiac tissue, there's some certain patterns that emerge when I'm talking about ischemia, um, and basically just the lack of oxygen in that particular tissue as it kind of shows up on an EKG. So, one of the first things that you may see is a hyperacute T wave. Okay, now again, this isn't a guarantee that this is the first thing that you're going to see, and it's not a guarantee that when you take this 12 lead that it's going to be there, or because it might have been there and it's gone away, or whatever the situation is. But either way, one of the first things that you typically see is a hyperacute T wave. So hyperacute T wave obviously refers to the T wave that we're going to be looking at. Now you'll notice a couple things here. Okay, I've drawn the isoelectric line as this is kind of my base for comparison. The peak of that T wave, if we follow these lines all the way up, peak of the T wave being like right here. Okay, it's far above this QRS. Okay, so if I'm looking at a hyperacute T wave, this is one of the big things that I'm looking for, because normally a T wave is not going to be bigger than the QRS, because the QRS is, quote unquote, massive amount of electricity in comparison to the others. So that is one of the big indicators that I look for when I'm looking for this kind of cardiac damage, is this hyperacute T wave. You'll notice one of the big things, I'll just kind of note again to remind you about T waves the way they should look. This T wave is asymmetrical. Most times pathological Q waves are going to be symmetrical. That's not what we're looking for here necessarily. So symmetrical, asymmetrical, either one. Just kind of look for that. Now, the next thing we're going to look for is the ST elevation. Okay, so ST elevation looks exactly something like this. And we're going to use the J point as our base of reference. And we're going to make sure that it is at least, that J point is at least 1 millimeter or more above the isoelectric line in order to be significant. Okay, so if I'm looking at this right here, if my J point was, let's say, right here, not significant. It's not over 1 millimeter. And again, 1 millimeter is just one tiny block. So if it's over one tiny block tall, then we're significant. As you can see here, this is many tiny blocks tall. Okay, because here's my isoelectric line. That's my line of reference right there. So this counts as ST elevation. So this is active cardiac damage being done right here. We know that we need to see this in 2 or more contiguous leads in order for it to be clinically significant as an MI. And we'll take a look at what that means here in the next little bit. So there's ST elevation. Now, one of the other things you may see is ST depression. Now, I'm not showing these in any kind of particular order. You may see ST depression first. You may see and then ST elevation, which is a very common kind of progression of things. But ST elevation, again, in order to find this or see this or count it, I use the J point as my reference right there, and I compare to the isoelectric line. And there's no hard number here. There's not like 1 block, 2 block, whatever. It's just my isoelectric line. The J point is below said line. Then I have ST depression. And it may even look something like this, where you do not have like a very clear and defined like J point. But you're just going to have to kind of use your best guesstimate right there to figure out where that falls. So that's ST depression. And then one of the other things that you'll probably see, and most of the time you'll see this later, is a pathological Q wave. Okay. Pathological Q wave is a sign of like not necessarily permanent damage. If you get it early enough, you can get rid of them, but this is like dead tissue is what this is beginning to form. Because normally, and this is important to understand, most leads, you're not going to normally see any kind of Q wave at all. Like it's just not going to be there. You can see one in lead 3 sometimes and it'd be, non-significant. But generally you don't see Q waves. Now you'll see QS waves like in V1 and V2, like that's normal. And AVR, you'll see QS waves, that's normal. But I'm talking about just a Q wave, right? So we're going to take a look a little bit deeper because Q waves have their own kind of criteria here, or I should say pathological Q waves have their own criteria. And so when I'm looking at these, what I'm looking for, two things, very simple, 0.04 seconds wide or more, 1 millimeter or more in height. So super simple to remember because all I want to do is I want to see if I am one tiny block wide and one tiny block tall. If I am greater than both of those, then I know I've got a pathological Q wave. So easy peasy, right? One tiny block wide, one tiny block tall. If I have both of those, I've got a pathological Q wave. It's just that easy, simple and done. So let's take a look at this 12 lead right here. Okay. Everything that we just talked about. Okay. When you're really beginning to interpret these things, first of all, step number one, we establish the rhythm because again, that's kind of the most important step. Step number two, you can just do a quick scan of the isoelectric line in each lead is what I generally do. Okay. So I go through and I scan like lead 1. Is there any ST elevation, depression, whatever, what have you? Like that's what I look for. So then I do it in lead 2, then lead 3, AVR, all these things. I don't really look at AVR for this. I kind of skip that, and we're going to talk more about AVR later. But I don't look at AVR for kind of any ST elevation or depression because it doesn't count as contiguous. Okay, which brings me to this term contiguous. Okay, so each one of these leads are grouped. And you have basically 3 groups, and these are grouped by where they look at in the heart. So we talked about this, I think, a little earlier. So I'm going to look at my lateral leads. So lateral leads again, 1, AVL, V5, V6. Do I have any ST elevation here? Again, I'm just going to compare that isoelectric line. I don't have any elevation here. I don't have it here. Now, draw it from here. Now, if you have a line that kind of jumps around, just look at the start of the QRS and draw it pretty much toward the end. And that's the best way to kind of figure out if there's ST elevation or not in there. But looking at these, I do have ST elevation in more than one of these leads. I've got ST depression in one in AVL. Okay. Because when I'm like looking for my J point, like let's say looking right here, this one is kind of messy, right? So maybe kind of hard to tell. But again, remember, this is all one moment in time, this column. So I can use this one because it's a little clear to figure out where my QRS ends. So that's going to put the J point here. Just follow that line down. It's going to put the J point kind of like right in here. And so clearly elevated right there. So, or clearly depressed, I should say. And then, going over to V5 and V6, I do have that ST elevation going on in those leads, because like here would be the J point kind of right in here. And so, it is greater than 1 block wide. And when I say, so I have it in V5, I have it in V6, they're in the same group. So again, lateral leads, looking at the lateral leads. So that means they're contiguous because I have it in 2 leads in the same group right here, okay? Now, that tells me that there's ischemia in that area. So in the lateral region, which that correlates to the left circumflex as far as like cardiac arteries go. So that's what that's telling me. Now, we're going to go ahead and look at the other leads, right? So we're going to look at the inferior leads, which again, that's 2, 3 in AVF. A lot easier to see here. Here's my isoelectric line because it's the start of that QRS. Wherever you draw your J point doesn't matter because it's elevated. Same thing here, same thing here. So I have ischemia in this inferior region, okay? So that correlates to the left anterior descending, maybe the right coronary artery. We have to do RV4 in order to figure that out. But note that later because you will need to do RV4s here. But it's in 2 of them, at least 2 of them. We have it in more, but because it's in 2 of them, that's contiguous. So that is, signs of STEMI. That is signs of an MI. I would call the STEMI line for this. And then looking through the septal/anterior leads here, I don't have it in V1, don't have it really in V2. V3, pretty easy to tell that I've got it, okay? You can see it very clearly, kind of right here, the sharp change in angle. That's what I'm using as my J point. Got it in V4. And again, that's contiguous because they're in the same group, right? And to note here, only in the precordial leads, which again is V1 through V6, if you have like them in a consecutive number. So if I have ST elevation in V4 and ST elevation in V5, that counts as contiguous. Only in the precordial leads because, like, geographically speaking, they are right next to each other. So although they're in different groups, like this V4 is anterior, V5 is lateral, because they're next to each other, V4 and V5, that counts as a STEMI, okay, STEMI activation criteria. So, with this one, we're going to call this a STEMI. Bam. Okay, very clear on this one, So let's look at this one. All right. Now, also forgot to mention, you can look for reciprocal changes here as well. That's a very common thing with MIs. So what I mean is, again, kind of like the axis where there's complementary, the inferior leads complement the lateral leads. So what I mean is, if you have like an MI in the left circumflex, right, in these lateral leads, it'll start to die there first. And then what's going to happen is that damage is going to bleed over to its neighbor eventually, okay? And the neighbor of the lateral is the inferior. So what you tend to see is, let's say, ST elevation in the lateral leads, and you may see ST depression in the inferior leads. That's what we call reciprocal changes. Now, in here, you don't really see it. But just to kind of illustrate the example, let's say that I have, I'll change color. Let's say that I have, ST elevation in this inferior lead and this one. If I look at the lateral lead right here, I see that, we're depressed. That's what I would call reciprocal changes. That's kind of another indicator that, yes, this guy's or girl is having an MI, heart attack. It's not a definitive thing. Like you don't have to have reciprocal changes in order to call a STEMI, but it's another kind of like affirmation that yes, this is happening. Okay. Now, I also, just to note, didn't see any really pathological Q waves here. So either A, it's like really early on, or just hasn't happened yet. Now let's take a look at this one. Again, so developing that technique, developing that pattern, I'm looking through here. I've established the ribbon to be a fib, and I'm scanning the isoelectric line in each lead for any kind of ST elevation or depression. And if you scan here really quick, you don't really see any ST elevation or depression. So that's, that's good. That's nice, right? But I will draw your attention though to right here. So let's look at the lead 3 here. And you're going to notice a Q wave with a tiny R wave following it. So if I'm going to define what a pathological Q wave is, this is probably a good example, because again, I need 1 block wide, and maybe if you squint hard enough, we'll be able to see it. It's kind of hard right there, and at least 1 block tall. Well, this is more than one like tiny block tall, right? This is a lot, and this is kind of like what it means to have a significant Q wave. You can kind of see it in AVF here. So again, looking for these Q waves kind of tells me maybe a little bit about this patient's cardiac history. Maybe they had a heart attack there before, and that's just the scar tissue there that's remnant over there. You don't see it in any of the other leads, so it might have been just the inferior that they had. So maybe the right coronary artery or left anterior descending. We really don't know. It's not really too significant for us to talk about, but so no STEMI on this one. But just a little thing to note right there, the Q wave. All right, so let's take a look at this one. Now, hot mess is what most people think when they look at this, because this has something else we're going to talk about later. For your reference, this has a right bundle branch block, but essentially, long story short, that makes a QRS wide, and it's not ventricular. Okay, so if I have wide QRS and it's not a ventricular rhythm, then it's a bundle branch block. Now, rules still apply here. Okay, I've established the rhythm. We're going to say it's, AFib, whatever it is. I'm scanning each lead for any kind of ST elevation or depression. Scanning real quick, isoelectric line, really not seeing it here, not seeing it there. Maybe you can count that as like depression. But again, I'm not looking for depression. Definitely depression here, because this is where my J point would be. So I have depression here. Doesn't mean I'm having a heart attack. All right. Does not mean that necessarily. You have to look at the way the patient presents is one of the big things here to determine whether that's damage being done. Got a little bit of depression here. But what I don't have is elevation, and I don't have it in 2 or more contiguous leads. So this is not going to be a STEMI. I do have like a pathological Q wave here. It's bigger and taller. It's more than a little 1 block wide and more than a block tall. And I've got one here and probably right here, right there. It's a little tough to see, but so with all that considered, this is not going to be counted as a STEMI. Okay. There's some things to look at. If the patient, for example, and we run in this to this a lot, if they don't have a doctor they go to regularly and they're like, yeah, everything's fine, and you see this, this would raise concern. This is like, you should definitely see a doctor, at some point soon, now, whatever that may be. But it's not a STEMI, okay? And kind of going back, those Q waves there, like if you look, inferior infarct, age undetermined. Okay, we're seeing this because of these Q waves. The computer's like, oh man, there's Q waves there, so maybe they had a maybe they had an infarct at some point in time, ischemia, infarction. So, there you have it.